Okay, hi and welcome to today's video. Today we're going to be looking at alcohols. We're going to look at how to draw them, identify them, and look at the substitution, primary, secondary and tertiary. Then we're going to look at substitution reactions, elimination reactions, and oxidation reactions. We may or may not get to oxidation reactions on this video. We shall just see how we go. Okay, so first and foremost, alcohols have an OH group, which is known as a hydroxyl group somewhere in them, and we name them with a suffix of OL or OL. Okay, they are identified as primary, secondary, or tertiary the same way as we identify haloalkanes. Now, let me show you some examples. Okay, so here we have some alcohols. I realise my drawing is not always the prettiest, but that's just what you get some days. Couple of things to notice. First off, our alcohol group is the OH. And what you will always see, my drawing might not always be the prettiest, but it is always going to show the carbon bonded to the oxygen, never the hydrogen. And that is why, on this particular one, I have it drawn as HO rather than OH, because that way you can see the bond is between the carbon and the oxygen. And that is something you should always do if you have an OH on the left hand end of your carbon chain. Okay, so primary, secondary and tertiary substitution. We've identified the carbon that has our alcohol or hydroxyl group attached to it, and what we're going to do is look and see how many carbons are attached to each side. And in this case, we have 2 carbons attached to the carbon that has the alcohol group, and so that is a secondary or 2-degree substituted alcohol. If we move along to the next one, we can see that this carbon has just 1 carbon attached to it. So this is a primary alcohol. And if we look at the bottom one, you can see that that carbon, circled in blue, has 1, 2, 3 carbons attached to it. So that is a tertiary alcohol. Now, if we are looking to name these, we're always going to follow the same pattern. We're going to start off by identifying our longest carbon chain. And in all 3 situations, our longest carbon chain is 3 carbons long. We have only single bonds between the carbons in that chain, so all of them are going to have prop because they have single bonds, prop because they're 3 carbons, and because they have single bonds, and ol because they have an alcohol. Now you can put the number into there, or you can put the number at the front of the name. So 1 propanol or propan 1-ol, and 2 propanol or propan 2-ol. The one at the bottom is very similar to propan 2-ol, but we also have this methyl group here on the second carbon, so this becomes 2-methyl propan 2-ol. Now, identifying primary, secondary and tertiary alcohols is a very important thing, okay? Because these really do have some very, very different types of reactions. So being able to identify them and being able to explain why is a good starting point. Okay, I would like to talk about the reactions now. So one of the reactions that alcohols undergo is a substitution reaction. And as I've described on previous videos, the definition of a substitution reaction is where one atom or group of atoms is replaced with another atom or group of atoms. In this case, the group of atoms that is being replaced is the OH, and what we are going to replace it with is a chlorine. And there are a whole bunch of reagents we can use for this. The most common ones are PCl3, PCl5 and SOCl2, or phosphorus trichloride, phosphorus pentachloride and thionyl chloride. Or, as one of my students once said to me, "Ah, right miss, that's pickle 3, pickle 5 and sockle 2. Whichever one makes it easier. However, to make life easy for yourself, I would recommend that you just remember the thionyl chloride, SOCl2. The reason being that it is the most powerful reagent and it will react with any alcohol under any situations. Most of the others will sometimes react and sometimes not. Okay, for tertiary alcohols, you can use concentrated hydrochloric acid, and my level 3 class I will demonstrate this reaction to you. Lucas reagent is also a possibility. Lucas reagent is basically concentrated hydrochloric acid with a zinc chloride catalyst. There's a lot of debate among chemistry teachers about whether or not Lucas reagent is part of the standard. I'm just going to very briefly mention it in passing, but I'm not going to discuss it in detail. Okay, so simple substitution reaction. We are replacing an alcohol with a chlorine, forming a haloalkane, and the reagent I recommend using is thionyl chloride. Let me show you. Okay, so here's the basic one. I've got a secondary alcohol. I'm going to use thionyl chloride as my reagent because I always recommend using thionyl chloride. There's no point in you memorizing a whole bunch of different reagents except for when you are having to identify the products from a reaction scheme. So don't bother trying to memorize all the reagents. Think, if I need to do a substitution with chlorine, I'm just going to use Sockle 2. And we're going to take our halogen, our hydroxyl group, our OH group, and we are just going to replace it with a chlorine. Everything else is going to stay the same. And this again is the beauty of writing the reagent over top of the arrow. You do not have to kind of sit there and go, I have to balance my equation. What happens to the sulfur and the oxygen and the other chlorine? You don't have to stress about that. All we're looking at is what the organic reactant and the organic product are. And there you can very clearly see you've gone from propan 2-ol to 2-chloropropane. End of story. Right, next one. As for haloalkanes, alcohols also undergo elimination reactions. And these are forming alkenes. So removing the OH group and a neighbouring hydrogen, forming an alkene. Water is the secondary product. And the reagent that we use for this is actually concentrated sulfuric acid. It must be concentrated. Okay, don't say 1 mole per litre, 1 mole per litre is not concentrated. Okay, just write down conc sulfuric acid. If you just write down sulfuric acid, it will not be considered sufficient as a reagent. Okay, must be concentrated sulfuric because that is a very different reagent. Concentrated sulfuric is a very strong dehydrating reagent. Because this reaction is forming water, something that dehydrates it is going to remove that water from the reaction, which is actually going to speed up the reaction. Okay, and as discussed in the video on Satchev's rule, this reaction can also form major and minor products if the alkene is asymmetrical. If the alcohol is asymmetrical and the OH is not on the end carbon. So just let me show you very briefly. Okay, so here again we have our simple alcohol. We're reacting it with conc sulfuric, and we are going to remove, in an elimination reaction, remember the definition is that we are going to remove the alcohol group plus a hydrogen from a neighbouring carbon. And when we do that, we will form an alkene. So now we just have our 2 hydrogens here, 1 on the middle one here, and then the 3 on the end carbon. And there we have our elimination reaction. Doesn't really matter how complicated your alcohol is, it's going to follow exactly the same process. And finally we come to oxidation reactions. And oxidation reactions are the point where there is a slight difference between the level 2 and level 3 syllabus. Okay. In both cases, tertiary alcohols don't get oxidized, and I'll show you why in a moment. In both cases, we use the same reagents. We use acidified potassium dichromate or acidified potassium permanganate, which are the ones that you may have used in redox. Where things start to differ is primary alcohols can be oxidized first to form aldehydes, and then the aldehyde is further oxidized to form a carboxylic acid. At level 2, this is pretty much taught as primary alcohols form carboxylic acids. At level 3, you need to be aware of those intermediate steps. At level 2, for secondary alcohols, you learn that they get oxidized, but you don't know what the product is. At level 3, secondary alcohols are oxidized to form ketones. So all I'm going to do today is just briefly show you those reactions. In my next video, I will talk about the formation of aldehydes and ketones in significantly more detail. Okay, so primary alcohols first are the easiest ones to consider. Primary alcohols are always found on the end of a carbon chain. Our reagents, permanganate is the first one, and I'm just going to remind you the colour change for permanganate in acidified conditions. We must have the acidified conditions. The acidified conditions here. That is really important. Okay, if it's not acidified, you're going to get different colour changes. So the colour change in this reaction is going to be purple to colourless. Now what happens in the first stage of the reaction is that the hydrogen off that carbon as well as the hydrogen off the oxygen are removed, and we get an aldehyde, which has a double bond oxygen on the end of a carbon chain. Now to make this, or to form this aldehyde and actually separate it out and purify it, is actually not easy, and there's a whole technique around that. So this requires a process called distillation, and I'll talk about this later. Okay. We can then also use more acidified permanganate or dichromate, and that will form our carboxylic acid by adding an extra oxygen into there. Okay, so that is the process at level 3, to follow that all the way around. At level 2, you can just jump from A to B. Same reagent. Okay. So secondary alcohols can also be oxidized, and again you can use either reagent. This time I've chosen to show you dichromate just because, again, it must have the H+. Sorry, yes, that is an H+. I know it doesn't really look like it. Just like with the aldehyde formation, we're taking away those two hydrogens, and we are going to form a double bond to the oxygen. And there we have our ketone. Tertiary alcohols cannot be oxidized because there is no hydrogen on the carbon with the OH group that can be removed. That is the simple deal with it. So there are the oxidation of primary and secondary alcohols, and I'll talk more about that in my next video. Thanks for watching.